Well, thank you so much for joining us today, everyone. I am Brooks. I'm with RudderStack. I'm a marketing manager, and am excited to have you all here for our webinar today on why Beyond Batch is the future. We are very excited to have a great panel of folks to chat about data processing with you today. So what we are going to cover really is how we got where we are today with batch systems. Then we're going to talk about why it's still popular, move into talking about event streaming, why it's the right approach, but what some of the pitfalls of event streaming are, and talk about what does the future really look like for kind of moving beyond batch. So to really give us the lowdown on all of this, like I said, we have a great group of panelists, Reis and Kostas Pardalis. I will do quick intros and then let you all kind of expand a bit. And can quickly kind of just hit the kind of catalyst of our webinar today. Probably about a month ago, Joe was on the DataStack Show podcast, which Kostas hosts, and we got into a conversation really about kind of batch data versus real time. And Joe made the point that essentially all data is real time, and that batching data is something that we as humans do because of technical limitations, but that's starting to change. So that's really kind of the catalyst for our webinar today. We're really excited to dig deep on that subject today. Joe has a varied background in lots of different data roles, in operations, in data science, data engineering. Now is in a consulting role as the CEO and co-founder of Ternary Data. Kostas is head of product at RudderStack. We are simplifying data pipelines and kind of providing a unified solution for moving data. So with that said, Joe, I'll let you expand a little bit. And Kostas, you can do the same, and we can jump into our conversation.
Cool. Hey, thanks. So my name is Reis. As mentioned, I'm with Ternary Data. So we're a data engineering, data architecture consulting firm based in Salt Lake City. And so I think we're known for helping companies evaluate the right data stacks and architectures. Then unlike a lot of other services companies that just come in and charge you hourly for a bunch of button share hours, we actually teach you how to use these tools in production. So we empower your teams to, be better versions of your data selves. So
great. Kostas, you want to share a little bit?
Yeah, of course. I'm Kostas Pardalis. As you said, Brooks, earlier, I'm head of product here at RudderStack. Before RudderStack, I was the CEO and one of the co-founders of Blendo. Blendo was cloud-based ETL solution. So again, I was building products around moving data around. I'm pretty much working. I have an engineering background. And before that, I was still I think I've been working with data-related technologies for more than 10 years now. That's my passion, and especially building products for data that are used by engineers and developers. So yeah, I had an amazing chat as part of the DataStack show with Joe. Many insights came from there, and this is a good opportunity to expand on these insights and have a deeper conversation around the difference between batch streaming and what's going on and what's going to happen in the near future in terms of these technologies and practices.
All right, so appreciate the intros, Joe, Kostas, and I'm excited to jump into our conversation about data processing today. And like I said, we really want to start with how do we get to where we are today with batch systems? So, Joe, I'll let you take this one first, and also want to see does either of you have a read on our "How did I get here" guy?
Yeah, it's Talking Heads, David Byrne.
Yeah, that's right. That's right. Well, Joe, can you help us figure out and kind of help David Byrne here understand how we got where we are with batch systems?
Well, I can't certainly answer where David Byrne how he got to where he is in that video. It's a classic video and song, but as far as how we got to batch, I mean, I think it's an interesting question, because on one hand, we've always existed in a world where data has been generated as events. But batch systems, I think, more accommodated the limitations of computational systems, as well. And if we're talking about, an analytics use case, which I think is the focus of today's chat, right? A lot of it had to do with the limitations of storage and compute historically. So, I mean, if you harken back to the early days of computing, even say the 50s and 60s and 70s and 80s and so forth, it's interesting because data might be entered as, might be saved in real time, but then of course getting the data out of those systems, required a lot more overhead than than you might see. You might find the capabilities of today's systems where you can just read records automatically as changes occur, and so I think that's really where the limitations started. And if you look at older analytical systems, we'll start with maybe Teradata, for instance. I think that was one of the first modern data warehouses back in the kind of the late 70s. I mean, it was a very expensive system, and it was completely batch, right? So you had to load it in batch, and you had to read from it very delicately because it didn't have a lot of horsepower, but for the time it was very sophisticated. As time went on, and I think as people started using commodity hardware to solve a lot of distributed computing problems, both with storing and writing and reading data, I think the notion started changing in terms of what could be possible with batch systems. Of course, this also sort of parallels the use of logs in systems, right? So in databases, you've always had the notion of like kind of time-based logs. But again, those were typically, data from databases was always read in batch. But I think, now that, compute and storage is caught up with the needs of streaming, and maybe things are, changing a bit. So what's your take, Kostas?
Yeah, I agree with you, Joe. I mean, I think it has to do with the evolution of how we work with data. And I think that just to better understand why we are here today and where we start, we need to start from where we started, right? Years ago, I mean, database is not something new, right? It's one of the first things that we have created as part of the technology. But there are different payloads when it comes to databases. We have the OLAP case, which is mainly for analytics purposes. We have OLTP, which is the transactional databases that, like PostgreSQL, for example, that we could use to drive an application. And these two things need to communicate. So traditionally, what was happening, we have a transactional database, data is created there. So of course, the data is at rest at that point, right? So you need to have a process who is going to pull the data from there and push it into the data warehouse, which is an OLAP system, to do the analytics. It made a lot of sense to do it in a batch fashion, not because the data did not have a streaming nature. Of course they did, but we were putting that buffer in between anyway, which was the transactional database. And of course, there were technological limitations there. There was cost-related issues, all these things that Joe mentioned. So it made a lot of sense to just follow a batch process, right? And I would put another dimension here, which is how easy it is to reason about the process itself how you can identify issues and how you can react to issues on a streaming system compared to a batch system. So a batch system is usually a bit safer. It's easier if something goes wrong to repeat the process. Data is more difficult to get to get lost in the process. So it made a lot of sense to have this kind of, let's say, architecture. And of course, the needs from the market were not that real time, right? Like, I mean, 20 years ago, marketeers didn't want to run campaigns like on real time, right? We were not like, none of the functions inside the company was mature enough to go and like use like real-time data. Now these things are changing, and today we are facing a completely different reality, and yeah, makes much more sense, and it's much more feasible to support and have streaming systems.
Yep. So Kostas, we've kind of hit on, you know, a lot of the reasons that it made sense to use batch. It's safer. The needs really just weren't there for real time, and getting kind of alluding to, you know, streaming. Before we get there, Joe, tell us a little bit about why is batch still popular? If we do see use cases for more real time, if technology is advancing, why are folks still using batch?
I think that the simple answer is that it's really convenient for a lot of reasons. So let's unpack the convenient part. You would have convenience in the sense that a lot of systems, analytical systems, OLAP databases, still tend to favor a batch paradigm, right? So even if you're talking about you know, popular data warehouses, a lot of those aren't built to ingest streaming data, right? You'd have to micro batch it to ingest, or you're going to probably break it. So column store databases are widely used, but there's definitely some limitations. And I would say and people have grown to tolerate batch. I think we'll touch on that in a bit. And I think that that's going to be less and less of a tolerated thing. But you know, on the source system end of things, you know, so if we start in the data engineering lifecycle, like this on the source systems, a lot of systems still, I wouldn't say favor batch, but like getting data out of these systems, whether you talk about an OLTP database or an API, it just makes it's just a lot easier just to pull records, yeah, in bulk, and then it, you know, through an ingestion mechanism, and then load those into a target OLAP system. It's also a lot easier to hire for batch. So if you look at the job requirements of maintaining a streaming system like a, you know, a Kafka or Flink or Spark, I mean, that's it's a pretty heavy duty skill set that's very expensive. And so I just think the confluence of these factors, and I'm probably missing a few, just lends, I guess, a sense of convenience to batch, right? It's familiar to a lot of people, and it's easy to wrap your head around. Yeah, you're not going to get your reports like maybe, you know, up to date for each hour or maybe for each day, but at least you'll get something. And so I think people tolerate it more than anything. So.
Yeah, absolutely. I totally agree with Joe on that. I mean, there's always inertia, right? Like there are people, I mean, the market itself, the industry was used to work in batch and think in batch, right? Change does not happen that fast, even in the tech industry, although we always think that like whatever happens in tech is happening really fast and change is always constant and all that stuff. But still, you have people who know how to set up these systems. There are technologies that are built around these systems, and all these things take time to change, right? So that's one of the reasons. And as I said earlier, just easier to work with batch systems. It's much easier to reason about. It's more safe. There are also, it's very interesting because I think there are also some paradigms out there, like the Lambda architecture, for example, which if someone sees like the typical example of Lambda architecture, you have the streaming side of things and the batch side of things. So they make them completely distinct in this architecture, which was and still is probably quite dominant when you are architecting like data infrastructure. And the main idea was that you stream the data if you want to do things like notifications, like real-time troubleshooting and things like this, right? So there was no concept of like using these streams to feed systems where you could do like analytics or like go back in the past and use like historical data to do that. And then you had the batch system, which was exactly for that reason. It was, okay, this is the slow process of like pulling the data, pushing the data into the data warehouse or the data lake. Let your data engineers and data scientists go there, build their models and all these things. And people follow, like people are mainly followers, right? There is a paradigm out there and we tend to follow this paradigm. I was doing the same thing and I'm still doing it. But things are changing and I think that we are going to see some kind of merge of this Lambda architecture into something where it's going to be like the differences between the streaming and the batching processes are not going to be that different. By the way, because Joe mentioned Kafka, Confluent, the company behind Kafka and the people behind Kafka, they came up with a new model called, a new architecture called Kappa architecture. And they tried to do exactly that. Like they were trying like to unify everything under like a streaming paradigm. So it's happening, just like everything else takes time.
Yeah, it takes a lot of time. I think Kappa, yeah, Kappa's an interesting one. I've seen some companies attempt it. And we'll talk more about this in a set when we talk about maybe some of the pitfalls of streaming. But I think some of the there's definitely some challenges around that architecture. It's a bit unwieldy if you're not really clear on how you're going to manage these systems. So again, that's why people I think just default to batch even when they try something like Kappa. It's just like, God, this is pretty hard. Then you end up with like, it's sort of Lambda and sort of Kappa, and then it's sort of none of the above and all the above.
Yeah.
So yeah, it's kind of interesting.
Yeah, I think you're absolutely right, Joe. I mean, first of all, like everyone who has tried like to set up and put into like an operational mode, something like Kafka or Spark, like these systems are not easy, right? Like it takes a lot of like people, a lot of knowledge, and it's still, if we want to see like a broader adoption and not just like in the large enterprise, we still need more tools to be built out there and improve the ergonomics around working with data streams and batches and all these things. These are like things that we still need work to make them like more approachable to more engineers out there.
Sure.
So things are moving past batch, but there are obviously still a lot of reasons to continue using batch. What are some of the things that we kind of get excited about thinking about streaming, thinking about moving beyond batch, Joe?
I mean, if we take a step back and understand, okay, so what's going to drive streaming and the growth of it, right? I think there's a stat from IDC. It was like 30% of data is going to be like streaming data by 2025. I don't know what the real number is. I mean, it depends how you define streaming as well. But some use cases, right? What this means is like as more people are using maybe mobile devices, for example, or just interacting with apps, IoT, self-driving cars, that kind of stuff. I mean, that's just a lot of data that's being generated. And so I think there's some, I'll talk about the cliched examples and I'll talk about maybe some stuff that, so the cliched examples is, you can do anomaly detection on streams, right? So that's a classic one. What else? You can look at e-commerce transactions and identify, and respond to, you can provide personalization in real time and react to inventory levels for your e-commerce site in real time. Maybe if you're running a promotion, you don't want to run promotions if inventories at 0, for example. self-driving cars, obviously, right? It's a streaming use case. If you ever thought of one, there's just a lot of data being generated off a self-driving car, and there's a lot of things you can do with the data there. So I'd say there's a lot of things you can do with streaming. I mean, if you zoom out too, it's kind of like, think of how you interact with your environment right now, and you always have, even before we had the internet, right? I mean, it's like you interact with the environment in real time. There's not really a sense of, I would say even past or present. It's just kind of you're just responding to the things that are occurring around you, and that's what I think is, to me, always been the holy grail of streaming. It's just computers are interacting with the environment in such a way that it's seamless. So I mean, obviously, there's a bit of ways to go with that in a universal sense, but if you can imagine like everything in a business, for example, occurring and being responded to in real time, I mean, that'd be an interesting thought experiment. Why do you have to have lags? I mean, we have lags because you have bottlenecks. But if you do a thought experiment, if you just removed all the bottlenecks and you had no lag between when an event occurs and when something needs to be acted upon, I find that a very interesting thing to think about. So, I mean, so to ask what can you do with streaming, I would say for a business, that would be an ideal. So.
Yeah. What I would add to what Joe is saying, that like in your question, Brooks, like pretty much you can do everything with streaming. Like it's not a matter of if there's something that you can do with streaming that you cannot do with batching. I mean, even in more like, let's say, advanced situations where like you are doing like you're training models, right? Or you have some advanced algorithms. Like in most cases, you will find like a streaming version of the algorithm. That's not so it's not that much about the limitations. Again, I will go back to the concept of like ergonomics, like how easy it is to do something with streaming compared to batching today. Some of the difficulties might be coming because of the nature of the two paradigms, which then we can debate that for some cases something might be easier to work with. But at the same time, a lot of like, let's say, the issues or the difficulties of working with streaming, again, I think that it's lack of tooling. I'll give an example. I was experimenting and playing around with a technology called Materialize, right? Which takes streams and can create like in very, very low latency materialized views of this data. And you do that by executing SQL queries. So you get the sense of like interacting with the database, but actually what you are doing is like you're interacting with live data, with streams, right? And the experience was amazing. It was really easy to set it up. It was really easy to connect to a Kafka stream or Kinesis stream or even like some files, local files. And it was magical. Like you could append entries on a file and you could see like in milliseconds that the table, the view was like updated. These are the type of tools that are missing. And as we create more and more of these tools, I think that we will see more of the stuff that we traditionally doing with batch processing to become available like in streaming fashion. And the biggest benefit, of course, is latency. I mean, that's the bottlenecks that Joe was talking about. Like you remove all these bottlenecks and actually you can react to whatever is happening as soon as possible. And that's super valuable for any business. Like that's what we are trying to do with technology, right? Now, there might be some specific cases where batch will be still important, but we can discuss about this, like questions you have, Brooks, later.
Yeah, that's great. Joe, you mentioned that the holy grail really is that machines kind of interact with the environment the same way we do as humans in real time. So why why is streaming the right approach? Is it just because it's the best way for us to kind of make that leap from batch to kind of real time?
I think it's a right approach. So, I mean, there might be other right approaches though that we aren't talking about and haven't even thought about yet. But I would think that like events, if you take a step back and like look at what events are, right? So the nature of an event is like, or the intention of an event is you notify, right, about something happened. You know, the source system generating the notification doesn't need to do anything. You know, or there might be some trade of state, like so a system will tell you that it did something and then it expects a response back, right? And so then there's a lot of other variations of types of events. But all these events though, right? I mean, well, let me take a step back and also kind of like maybe give it an opposite example. And so right now, when somebody enters data into a form, the data just goes into a database, and then what happens? No idea. Somebody may take the data and do something with it. A system may use that event to trigger some downstream action. But in the former case, if it just sits there, I mean, what good is that? I mean, you might use that data for later, and I guess that's fine. But if you're able to have reactive systems that simply respond, maybe as events are generated, I would think that that would give your organization just a lot more agility to be responsive. And you see this even with I mean, there's endless tools out there that sort of do this right now. Like Zapier comes to mind as one that's just more of a consumer end product, right, where things happen and you can engineer pipelines to do stuff. I think what's starting to happen though is you're starting to see more intelligent automation with streams as well. So that, as Kostas points to, like kind of incorporating machine learning. This has been missing in a lot of cases, right? Because it's been very heuristic based, if else statements, for example, or case statements or something like that in code. But having intelligent systems just decide an action to take. I mean, that's I mean, a lot of bigger companies have been doing that for a while, but I think the democratization of that will be fascinating to watch unfold as those same capabilities sort becoming available to small medium businesses, for example. And so why is streaming the right approach? I guess it's the right approach because it removes bottlenecks. So unless you like bottlenecks, and I think bottlenecks actually serve a purpose in some cases, right? Bureaucracy is good in some cases. You may want things to move slower. So, but I think if you have the option of doing streaming and implementing it when it's necessary, then I think that should be it should be the I think the default approach. So,
Kostas, anything to add?
Not really, to be honest. I think Joe gave like an excellent description of why streaming is the right approach. I would just add something that's a bit more philosophical. Let's say, I mean, at the end, time is probably the most valuable resource that we have. So, and that's why we want automation, and that's why we have technology, right? Like we are trying to utilize our time like in the best possible way. So, and streaming is exactly that. Like it's a paradigm where when something happens, as fast as it happens, we react to it. We don't wait for something to else to happen, and then we'll see, and all these things. So that's my opinion. Outside of this, I think that like Joe gave like an excellent description of why streaming is the right approach.
That's great. Well, Joe, you have hit on this a little bit, but tell us what are some of the pitfalls to streaming? What's pitfall here you need to be on the lookout for when it comes to streaming?
Gosh, you're clairvoyant about my childhood in the 80s. It's hilarious. I listened to a lot of Talking Heads and played this game a lot. So the pitfalls, okay, so I think there's a few. obviously we kind of talked about in the first part of the slides, really, right, where batch is sort of the default, still here to stay. I think the pitfalls the pitfalls, I would say, not of, but to streaming, is just basically inertia and organizational willpower to change. That said, some of the pitfalls that I see of streaming systems right now are basically on, if you go to the source system end of things, you may have to pull from APIs. And so you're going to have an inherent lag there because not a lot of systems are set up to provide default streaming outputs, right? Because some of those systems as well, they rely on basically batching up data in a transactional database, for example, and then sending that off. Change data capture is one where I think there's, obviously people are seeing a lot of success with that. And there's other things, and log systems and so forth. I mean, it's just, I think the pitfalls when you talk about source systems are just, I think teams making sure that the source systems are capable of providing a good streaming experience and not also simultaneously crashing the production system that it's coming from. I've seen people try and do, streaming out of source systems and then compromising their production database that they're reading from. That's never a good idea. Try not to do that. But then, you start getting into ingestion. I think there's no shortage of tools right now that can help with streaming. Although I think it's still immature. Like a true stream processing system right now is, I think the closest one that I've seen so far is Flink, and that's still got a lot of overhead, to stand up. I think it's getting easier, but and then you have other ones like Spark, which I think more do kind of micro batching, and so forth. But you're starting to see more interest in this ecosystem, and you bring up Materialize. That's another one. I think there's a lot of promise in these types of solutions. But the question I have, I like your take on this too, Kostas, is like, okay, so say that you do streaming. One of the big cruxes I see right now, one of the benefits of doing traditional OLAP is that you have the sense of dimensional modeling. The Kimball style, for as much as people deride it, I think there's still a lot of benefit in Kimball in the sense where you can reason about your business definitions in a way that I think streaming, at least at this point, it makes it a lot more complicated to reason about traditional notions of facts and dimensions. And again, facts and dimensions, I think, are still there's a reason Kimball's been around for a really long time and people use it. And it's not because it sucks. It's because it works really well for a lot of business use cases. And no matter how hard people have tried, I've been in this game for a really long time, and I've seen people say, Kimball methodology is on the way out, or dimensional modeling is like old school and should be thrown to the dustbin of history. And every single time it's like I see people coming back to it. It's like, well, how else am I gonna reconcile business definitions? That's a big crux I see with streaming right now, is even if you can stream into like a Druid or something like that, which is more capable, I think, of handling ingestion of streaming data, you still got the business definitions to contend with. So
yeah, that's a very, very interesting point that you're making there. And I feel like we are going to have, let's say, some kind of repetition of what happened with NoSQL and SQL, where it was the end of the SQL database.
Right.
Like, who needs them, right? But I think that when a paradigm, an architecture, or a technology is proven for 30 years, 40 years, maybe, I think there is a reason, right? There's so much value that has been built on top of that. It's proven. So I don't think that we should be trying to dismiss it. We should try and see how it can fit in, let's say, more agile or more flexible architecture in the future. And I think that one of the main differences that I think will happen is that instead of considering that you have the data warehouse, right, and everything needs to be under this Kimball style modeling over there, which is the reason that in the past we had ETL and now we are talking more about ELT, right? Because we had to transform the data on the fly and to fit the data model at the end. is that things will be much more relaxed in terms of like the first layer of storage of the data. And that's, I think, that where data lakes are going to become even more important, where you can store the data there, be much more relaxed in terms of how the data is stored. And I think with streaming data especially, and even for the databases, using something like a CDC approach to pull events from there, you can keep like a whole history of exactly what and when happened on your database. You can replicate whatever state you want, right, in time, which is amazing. And it's cheap enough right now to do it with the storage out there on the cloud. And the data warehouse for the dimensional kind of analysis and all these things, it's going to be not the centerpiece of what we are doing in our data stack, but just one part that will take the data from something like a data lake, model it in the right way, right? And drive very specific use cases inside the organization, like the traditional BI, which always will be there. It's not going anywhere. Like, we need BI. We need to understand the past before we try to predict the future anyway. So that's what I see, and it took me a while to mature enough to understand that like these kind of technologies are not going away.
Right.
They just need to be repositioned.
Yeah, I like that. I like the comparison with the NoSQL days, because it was almost like this bratty teenager that was like rebelling against the parents.
Yeah.
Like, oh yeah, we don't need you anymore. And then, yeah, I mean, it's interesting because take a look at, like Spark was supposed to kill the, the data warehouse, and now it has SQL in it, right? And like Snowflake, I mean, they're doing pretty well. Last time I checked, they're SQL first. So it's been an interesting renaissance of, and even like Druid, for example, they got some notion of SQL in it as well, right? So it's like all these highly performant, databases. I mean, they all have, superior powers in their respective areas, and they all use SQL on top. Yeah, it is interesting. The other piece I would say too, that I mean, there's a lot of research and development in this area, but it's continuous learning of machine learning models. So the ability to, retrain, in real time, and learn. So that's something where I think it's still pretty early days in that area, but like things like catastrophic forgetting, for example, right? Like that's being addressed by researchers right now, and I think that'll be a fascinating area to sort of. So what I'm interested in too is just sort of the reconciliation of just kind of what you described, the source to use cases really, and sort of the mushy layer in between, like sort of what happens with the streaming, ingestion, storage, transformations and stuff, and data quality too. Data governance is another thing, right? Like that does that change in a streaming first paradigm? I know that there's, projects that are starting to, look into this and see, like, I think Great Expectations is maybe going to start considering more streaming use cases. I think, I don't know, but I would imagine so. And DBT, I think they're starting to maybe try and look at transformations and streaming as well, but it's because it's still early days.
Yeah, absolutely. And actually, something that I've seen like a couple of weeks ago, like Materialize, for example, now also has support for DBT models, which makes a very interesting transition for DBT to get into the streaming world, right?
Yep.
And that's something that I wanted to add, that actually you can see like the power of SQL at the end and how important it is also by technologies like DBT, right? Like DBT became like extremely popular because it could give what was missing from SQL, right? And suddenly when you had all these missing parts from this language, for the ergonomics of the language, you see like how powerful it can be, especially for people who are more of the analyst side of things, not like pure engineers, right? So
that's a good point too with respect to streaming. Right now, I think a lot of the streaming technologies, there's still quite a bit of gatekeeping because these are very complicated pieces of technology. It's not like spinning up a database or something. There's a lot to these things, right? Distributed systems. You could use Mesos or Kubernetes or Yarn or whatever you want, but like there's a lot of moving parts. Then you got to understand, okay, so I got to understand how to run a distributed system. So I highly doubt you're going to be running these systems on your laptop. So, you know, and I think the layers of abstraction in this are starting to, you know, starting to be simplified for people maybe. So, you know, and then you can always look at the cloud solutions too. I mean, there's plenty of good things that the clouds provide out of the box that, you know, you might want to look at, like in AWS, there's Kinesis, and that I think for a lot of people works just fine. You know, and then even for simple message brokers like SQS, you know, those will work fine. And then Google has PubSub, and I think when Spotify did their trial of it, I think that the stat was like they threw like 2 million events per second at PubSub or something, and it didn't even skip a beat when they're testing it. It just worked. So,
Yep.
You know, I don't think there's very many knobs to tune with PubSub at all. So, point being, it's like if you're interested in streaming, I mean, there's a lot of complexity, and maybe the first thing you should do is try not to roll your own. Try and find something managed out there, or there, you know, if you can find a third-party provider, you know, RudderStack or somebody else to handle your data ingestion, then you know, simplify your life a bit. Don't you know, there's no reason to roll your own stuff in these day and age unless you have a competitive advantage of doing so. So
yeah, that's an excellent point, and it's one of like the main pitfalls that I also see with streaming is because it's such a complex technology and new technology and still maturing. It's very easy for people to over-engineer solutions.
Big
so
time.
As with everything else in engineering, you always have to be very, very careful not to over-engineer solutions.
Mm-hmm.
And it's easier to do it with a streaming platform compared to getting like a traditional database and spin it up and start using it right.
I would say the other pitfalls too. Yeah, I mean, you bring up an interesting point, and what I've seen is maybe engineering teams. They, you know, there's the phenomenon of resume-driven development. I think is a real thing where, you know, it's like, oh, I can put Kafka on my resume or something, so I'm going to do that. And so you're going to take these. You're going to introduce Kafka into a system where perhaps data quality right now or data is hard to reconcile even in a batch system. But now you're going to introduce Kafka on top of it. So all you're doing is basically doing dumb things faster. And you haven't actually solved the root issue. You're actually just perpetuating something and you know, you're taking bad habits and putting them on light speed. So,
yeah.
Which I mean, if your boss is cool with that, go for it. But I don't think that'll be I think the business is going to like that too much. So.
Yeah, 100%. I totally agree on that. Yeah.
We are in an exciting point, I think, with, you know, everything moving towards Joe. You kind of said streaming first, but batch is not going away. So bring us home, Joe, and just talk about kind of why is moving beyond batch the future. And you know, batch is likely always going to have its place, but why do we move? Why do we move beyond it?
Yeah, I mean, it's interesting because I always think of batch as a special case of streaming, actually, because back to our original discussion back on the DataStack show, it's like all data at some point originated as real-time event data. When it was input manually or through an automated process, that those were events, and then somehow they got stuck maybe in a database, and then you got to move them out, right? But I think these are artificial constraints, and because technology is, and I would say very gifted teams are not focusing on the problem of sort of removing those bottlenecks. Moving beyond batch is just, it's going to be a natural consequence. If you can get as close to the event as possible and respond to it, then I think that notion is very attractive to individuals and companies. But, you know, so yeah, it's interesting because it's like real time's always been with us and it'll continue being with us. But and I would say for a lot of cases, a batch isn't going anywhere. Just it's a convenient construct, but it's an artificial construct. So what are your thoughts, Kostas?
Yeah, I mean, I think we gave many reasons during this conversation about why we need something more than just bots, and why we might see like some kind of rebalancing between the importance of bots and streaming inside the company. I'll repeat again that, like, for me, the most important reason is latency at the end. Like, it's how fast we can react to what is happening out there, and to do that at scale. And in order to do that, we definitely need to go beyond bots. Bots will still be there. There's no, we don't have to chat about that, to be honest. But more and more we will see traditional use cases around bots processing to become part of a streaming environment. So yeah, we'll see. I think we are living in a very interesting times for anything that has to do with data in general, and with data processing more specifically.
Yeah, I mean, that said, it'll be interesting to revisit these types of conversations in a few years, right? Because like I think you're right, Kostas, we're living in an inflection point right now, in in real time, and no pun intended, but it's like we are literally going through this I'd say almost this weird renaissance phase of the of data architectures and concepts even. I think it's a recognition that batch isn't adequate enough for a lot of use cases, but we're still in the very, very early stages of what that next step looks like. And there's a lot of very smart people working to solve this problem, receiving a lot of money from VCs and big companies. And I don't know, I'm fascinated. I'm just kind of along for the ride, frankly. Who knows? And we could all be wrong. Maybe everything is just going to be batch, for the next 50 years. So kind of doubt it, but you never know. So
100%.
We shall see. Time will tell, that's for sure.
mm-hmm.
Well, Kostas, Joe, thank you so much for your time and insight today. I know we're coming up on time here, but we do have a few questions. So want to move into a quick kind of question and answer session. Really kind of either of you can take this one. But we do have a question from an attendee. Given that the limitations preventing real-time data are often not CDPs or warehouses, but rather destinations like Marketo, SFDC, and so on, when do you think real-time streaming of event user account data is feasible based on support from destinations?
That is a big bottleneck. I SFDC, I think that's Snowflake Data Cloud or okay, Salesforce Data Cloud. I don't know.
Yeah, it's
anyway,
Salesforce.
Salesforce. Okay. I mean, I think it just depends on how willing those destinations are to treat streaming as a first-class citizen. Otherwise, there's not a lot you're going to be able to do about it, and that's simple fact. So there needs to be enough market demand for these platforms to change, but a lot of it's probably architectural limitations too of these underlying systems, and that's going to take a lot of time to reconstruct. I mean, you can only look at AWS Redshift, for example, that was built on Postgres, a forked version of it with ParaXL underneath it, and it's still that. It's there. I know AWS is working really hard to address some of the limitations of Redshift, but you see what even a company like AWS and the resources it has to kind of modernize Redshift is just, it's a fundamentally huge undertaking. It's going to just take time. So, and you're not going to make those investments unless there's competition that's forcing you to do this, or a good business reason to do it. So yeah, the attendee's absolutely spot on the observation. This is a big bottleneck, but
yeah, it's also a big opportunity to build a new Salesforce, right? So
yep,
that's great. Well, if we do have one more question, if y'all have time for one more. So real-time data is often more costly due to API limits, or worse, error prone due to rate limits. Do you see a shift in the market from larger players that make this less of an issue?
Take that one, Kostas.
Yeah, sure. I think the answer is like similar to the previous question, to be honest.
Yeah.
So yeah, the limitations are still there, right? And the best way to remove the limitation is by having the need out there for this kind of processing, right? So what I think is going to happen is that as more and more pressure is going to put by customers for this kind of infrastructure, we will see like these limitations going away, and the prices will go down. I think it's like just market dynamics at the end that they are going to drive this. So yeah, I mean, I'm much more, I feel much more, let's say, confident that if we have this kind of limitations on something like a cloud environment or cloud infrastructure, this is much easier to be addressed. So yeah, I would feel like AWS, GCP, they are going to react much faster to these changes, and they have the capacity to do it. As Joe was saying, re-architecting something like Marketo is probably much harder as a task. So that's something that probably has more risk and probably it's going to be much slower. But I'm pretty sure that like you can see that like if you see, for example, Snowflake, right? Which they started as a transitional data warehouse, but they have like streaming capabilities right now. You can stream data inside the data warehouse. Same thing even with Redshift, which is a much older technology. So I feel much more confident in these technology providers, let's say, especially the cloud providers, that they provide the infrastructure, that things will going to progress much faster there towards streaming solutions.
Yeah, and again, it comes back to just what's the demand for it. You know, I've been on teams where we built APIs, and typically these only happen when there's requests to do so, right? Because I mean, as an engineering team, you're going to be very busy dealing with technical debt and new features, and unless your new feature from your product manager happens to be, APIs that overcome the limits of pagination or rate limits, it's like you're going to get what you're going to get. And so, my advice is, if you have a favorite API you'd like to get real-time data from, just go bug the hell out of the company and keep asking them for it, and get all your friends to do it too, and pay them money, this kind of thing, right? But it's not going to happen on its own. That's just your biggest bottleneck. Really is just like, I think, human beings at the end of the day, and the fact that we're pretty lazy, and unless there's an overwhelming reason for us to make our APIs more available to people, it's like, why are we going to do that? We aren't. It's a simple fact. So money talks, and that's a simple fact. So
that's good. Well, I think the theme of today is we're in a very exciting, we're at a very exciting point, and time will tell as things continue moving towards kind of this event first paradigm. So yeah, I think it's just exciting. Joe, like you said, maybe in 5 years we will do another webinar looking back on this conversation. We'll see if we got it right.
Sure. That's my favorite kinds. I mean, it's always fun to prognosticate about the future, but I think it's more fun to figure out where you got it right and wrong. So, and
that's great.
So awesome. Well, thanks for having me on.
Well, Joe, Kostas, thank you again for your time. Everyone, thanks for joining us. Be sure to check out RudderStack.com and TernaryData.com, and we'll see you next time. Thanks.
All right. See y'all.
Bye.